And hi Professor Chen, this is my first video of this week, and this video is about question 1. And x, y are independent with f(x)(x) equal to the ux minus 1 minus ux minus 2, and f(y)(y) equal to the uy minus 1, and z equal to the x plus y. And we need to find the probability density function of z by these two different methods. And the first question asks us to use the convolution method. And the second question asks us to use the geometric method. So let's focus on the first question first. And these are all conditions the question offered to us. And with convolution method, we just need to apply this function and this function into this equation here, and then integrate this part from the negative infinity to the positive infinity to find the fzz. And yeah, we can find that if we apply f(x)(x) and f(y)(y) into this equation here, we can find we just need to integrate this part from the negative infinity to the positive infinity to find what fzz looks like. So we need to discuss fx alpha and fyz minus alpha in order to integrate this part here. With fxx and fyy here, we can find that fx alpha equal to 1 for alpha located in the range between 1 to 2, and fx alpha would be 0 otherwise. Fyz minus alpha would be 1 for alpha located in the range between the z minus 1 to z, and fyz minus alpha would be 0 otherwise. And in order to integrate this part, we have to find the intersection of these two different range, the 1 to 2 and 0 and z minus 1 to z. And first we need to, so in order to find the intersection of these two different range, we need to discuss different z here, because with different z there would be different intersection here. And first, when z less than 1, there would be no intersection here. There would be no intersection of these range and these range, so this part would be 0. And also when z greater than 3, this part would also be 0, because there is also no intersection here. And when z located the range between the 1 to 2, the intersection would be 1 to z, so we just need to integrate this part, which is 1 from the 1 to z to find what fzz looks like. And the second and the next circumstance is when z located the range between the 2 to 3, and the intersection would be z minus 1 to 2. So we can just integral the 1 from the z minus 1 to 2 to find what fzz looks like. So in general, the fzz equal to the z minus 1 when z located the range between the 1 to 2, and fzz equal to 3 minus z when z located the range between the 2 to 3, and fzz would be 0 otherwise. And the second question, we need to use the geometric method to find the probability density function of z. And in order to use this method, we need to find what fxy looks like. And from the question, we can know that x and y are independent, so fxy equal to the fxx multiplied the fyy, which would be like this. And then we need to draw the non-zero definition region of xy, and which it looks like this, a square. And which means if we integral fxy on this area, we will get 1. And we also know the relationship between the z and xy with z equal to the x plus y. And first we need to use fxy to find the probability distribution function of z, and then we differentiate the probability distribution function so we can find fzz. the probability density function. And with the definition, with the definition of probability distribution function, fzz equal to the probability when z less than z, which means we need to make sure the x plus y less than z. So we just need to draw a line in this diagram to find the intersection of this region, the non-zero definition region here, and the region which x plus y less than z. And these two, the intersection, we also need to discuss the different circumstances of the intersection here. And first, when z located the range between the 1 to 2, the intersection would be like this. And we just need to integral the f(x, y) in this little triangle here to find what the fzz looks like in the range between 1 to 2. And the second circumstance we need to discuss when z located the range between the 2 to 3, and the intersection would be in this area, but with the definition of the probability distribution function, we just need to use 1 to minus the integration of x, y in this area, this little triangle here, to find what fzz looks like in the range between the 2 to 3. So the first circumstance, the fzz is this, and the second circumstance, the fzz is this, and then we just need to differentiate the fzz probability distribution function of z to find the fzz here. And so this is my answer here. Thank you.